I'm CK. Tonight we've got a utility module from Joranalogue, their Test 3. It's a module that will show you the electrical characteristics of another module or modules. I need it for a project I've got coming up, so I wanted to put this together and see how it works. Hope you enjoy the video. And here we are from Joranalogue, the Test 3. I picked this up from thonk.co.uk, as I do many of my modules. Open the bag up. Got that bag, and we've got that bag inside this bag. And there's nothing else in there. So again, it's Audio Design Test 3, eurorack, voltage, and milliamp meter. And the build instructions are there. And this feels like the front panel. So let's get that open first. There's some stuff in the bottom. That's it. Got some knobby type things. Got some more knobby type things, or spacers, and then some Allen head screws and an Allen wrench included, and some more spacers. Joranalogue Audio Design. That'll go up on the sticker wall. 2 screws, probably rack mount screws. Now here's the front panel. Let's see what we got. V milliamp meter, test 3. Display will go here. These are nice countersunk holes. That's nice. So you can, I'm assuming these 2 are buttons, and you can switch between the 5, positive 5, positive 12, and negative 12 volt rails. And you can look at voltage, milliamps, and peak milliamps, I believe. That's pretty straightforward. Let's look in the other bag. I don't think there's a lot of assembly in this one. Here's the circuit board, and as you can see, it's got quite a bit of surface mount already installed. Display will go here, a bunch of resistors to buffer that, some LEDs telling you the mode, a diode just kind of hanging out there, microcontroller that it's an Atmel, but I can't read the number. A couple of electrolytic caps, some other controller chips along the way, I'm not sure what they are. Transistor down there, power supply and meter output. And then an ISP connector if you want to program it, I guess. 2 switches, so there's not a whole heck of a lot to solder on this one. Got a power connector, full width, not just 10 pin on one end, but it's full width on both ends. Should be nice. Then in here, I will cut this bag open, as is my wont. We've got 2 power connectors here. One for, I guess that's for, oh, I know, never mind. This is the connector that you'll plug the module under test into, like so, in there. And this is the one that goes on the back to actually pull power to drive this device and pass power along. And then we've got our display. I think it's a dumb display. Yeah, it's a dumb display. Then in this bag we should have the LEDs and the switches. And we've got 1, 2, 3, 1, 2, 3, 4, 5, 6. And we've got 6. But they look white, but they probably are not white. So let's power up the meter in continuity mode and see what color these LEDs actually are. It's kind of bluish white. Okay, so there you go. And they have a build guide. I don't think we need a build guide for this. I'm going to go out on a limb here saying, since all we can connect are 2 power connectors, 6 LEDs, 2 switches, and a display, I don't think we need much of a build guide. However, I'm going to go take a look at the build guide just to make sure there aren't any gotchas that we don't know about that may mess up the build when we do it. So I'll get the soldering iron heated up, take a look at the build guide, and we'll put this thing together. Now the build guide did remind us of one thing, which is this can be built one of 2 ways. It can be built so it's completely open with both connectors on the front side, if you're using it on your workbench or whatever, or if you're going to be using it in the rack, then of course the power connector goes on the back side. So either way, whichever suits you, I'm going to build it as a rack module because that's what I intend to use it for in the little project I've got coming up. So we'll put it together. So that means when you're doing we're going to start with the LEDs. Obviously we've only got 6, 7, 8, 9, 10, 11 things to solder on. But it's a little more interesting when we're doing the kit as a panel mount. Because what we're going to do is they've included these spacers, which I've used before. Division 6 uses them on their sequencer, and what this does, it spaces the LED out from the board, like so that when you put the front panel on, it's poking through. Let's see, let's get one of these spacers on so you can get a better idea. If we had the LED, if we didn't have a little spacer thing in there, the LED would be flat to the board like so, and it wouldn't go through. But with the little plastic spacer, then the LED pokes through. So that's what that's for, and we're going to do it that way. Because again, I'm going to be building this as a rack module. I like these little spacers. These are a little beefier than the ones that Division 6 uses. Bring my soldering pad in for a minute so these guys don't fall out. I'll hold them with a little index card just for a second, and put this little piece of foam, handy piece of foam, so it doesn't fall over. Grab some solder, and I'm going to solder one leg of each. And now, as you can see, they're all little out of place, so I will just heat the solder up again. Let it cool. I'm going to put the front panel on, kinda. adjust that. Do a little more tweaking. And that all looks good. So now I can go ahead and solder the other legs. Now put the two tack switches in, if they're not going to hop all over the board. And put the two connectors on. Where did I put the two connectors? Here they are. There's a little cutout for the keying. Put that one on first. Of course the pins came out when I flipped it over. In fact, it won't stay, so let me get a little piece of foam. And there's the connectors. Now the display, and of course the dots or decimal points on the display go down at the bottom. They go like that, and I will need my foam again to keep that flat against the circuit board. Now we'll put the board together. First we'll take 4 spacers. Oh, these are good. These are good nuts. They're fiber lock nuts, which is nice. Got to get a little something to drive these. 1 second. They're in place. Now one thing, since we had standoffs for the LEDs, we need standoffs for the switches too. So we will put them on. Put the front panel on for permanently. So we'll line up all our stuff that's already pretty much aligned. Take our little flush mounted countersunk heads. Put the power cable in. And that's it. There's the front, side, back, other side, top, and the bottom. Not much of a build, because it was all surface mount, but got some interesting little bits to it. Now let me drag some crap out and we will give this a quick test. I've got a little eurorack power supply from Frequency Central here that I'm driving this with, and it'll pass power on to, this is a VCO from Look Mum No Computer that I built a month or two ago. You can look it up on my channel. It's a good VCO. So let's plug in the power and see what we get. Okay, good. So it just ran through its startup sequence. Can you see the numbers on the, yeah. So it's showing positive 12 volts. There's the negative 12 volt rail. There's the 5 volt rail. We're seeing volts. Now if we look at milliamps, we're seeing nothing because nothing's plugged in. I'm going to turn this off. That help? Who knows? I got to get better at videoing LED displays. No peak either. So it's all peak voltage. Why is that showing 19? Why is it? Oh, there it goes. Now it just dropped to 12. Huh, that was kind of unusual. So I'm going to plug the VCO in, and the meter should change, maybe. Okay, you saw the peak flashing because it's picking up different peak amperages. So this is 49 milliamps on the plus 12 rail, 17 milliamps on the minus 12 rail, 0 milliamps on the 5, which makes sense. Now I just changed, let me back off a little bit, other back off. Now I'm changing voices on here. Huh, I got some, there. We're getting different voltages as I adjust knobs. See what the negative rail is doing, nothing much. Current's not, I don't think this is drawing from the negative rail. Back to positive. 56 milliamps. Peak was 61 on the positive rail, 25 on the negative rail, and of course again 0 on the 5 volt. See if we see any voltage fluctuation as I go through here and change various things, change the tuning and so on. Not seeing much of nothing. So that's what it does. It's a good way to check to make sure the module you've just built is actually drawing the current you expect, because you don't want to overload your skid or your power supply in your studio rack or whatever. You can also say chain this with a chain cable and maximize your loading. So that's all pretty cool, and again went together very, very quickly. But it's a good little unit, and over the next little while you'll see where I'm going to end up using it. And I hope you enjoyed this video.